Welcome to Math 31. This is the second part of the lesson on combined rules or combining rules. Now in your lesson notes you'll have a series of questions, extra questions, and I'm going to do not number 5 nor number 6 because they're kind of repeats of what you've seen before. In fact, number 5 is in the textbook. Didn't realize that. Instead, I'm going to go to number 8 and number 9. And because these ones illustrate principles that we've seen, but not to the extent that they're visible here. Now, number 8, when you get a complex fraction like this, you can do all sorts of things with it. You could use the quotient rule with it right away, and that's totally fine. But it does, it really lends itself to a simplification first. So my advice would be to simplify first, and see where that takes you. So this numerator, it's a fairly routine looking problem actually. The common denominator on top will be x minus 1, x minus 2. So we simplify that numerator, so the 2 has to get multiplied by x minus 2, and then 1 times x minus 1, and then this is all over top of 3x minus 5. And then y is equal to, going further, 2x minus 4 plus x minus 1 all over x minus 1 times x plus, or x minus 2, where'd that come from? And then this is all over 3x minus 5. And then finally we get y is equal to x minus 5 3x minus 5, add those ones together, over x minus 1 times x minus 2, and then this is over 3x minus 5. Now what you're going to get either in one step or in two, I'll do it in two just for safety's sake. We're dividing by 3x minus 5, so times by 1 over 3x minus 5. These cancel out, of course, divide out, so you get y is equal to 1 over x minus 1 times x minus 2. Now, better to take this one and FOIL it out, so you get x squared minus 3x plus 2. And then y is equal to x squared minus 3x plus 2 to the negative 1. So this question now is really a pretty straightforward chain rule problem. So dy dx is equal to negative x squared minus 3x plus 2 to the negative 2 multiplied by the derivative of the inner, which I will write out in this form. So d dx x squared minus 3x plus 2. And then it's 2x minus 3. And then dy dx is equal to negative x squared minus 3x plus 2 to the negative 2. And to finish it off, I will write the denominator, or I'll put this on the denominator with a positive exponent, leaving me with negative 2x minus 3. So the question really wasn't that sophisticated in terms of combining rules. Just another reminder, simplify first before you do any differentiation if possible. Now the next question, number 9, is one that will push you a little bit. So it's an example of, it's not really combining rules because it's just the chain rule, but you will have to do the chain rule several times. So first, make sure that you get this one set up properly. This is the cube root, so to the 1/3 of 1 plus, and then another bracket, 1 plus x to the 1/4 all to the 1/2. So first, make sure that you get it set up properly in exponential form. So this is a function inside a function inside a function, and I think maybe inside another function. So when we take the derivative of it, we start on the outside and work our way through it. So dy dx is equal to 1/3 times 1 plus bracket 1 plus x to the 1/4 to the 1/2, all of this to the negative 2/3, multiplied by the derivative of that inner, which is 1 plus x to the 1/4, all this to the 1/2. And then with care, work down. So when we take the derivative of that inner expression, where the derivative of 1 is 0, then the derivative of, excuse me, I've got this bracket in the wrong place. There we are. So that 1/2 really just belongs to the 1 plus x to the 1/4. So now we take the derivative of this, and we get 1/2 times 1 plus x to the 1/4 to the negative 1/2, subtracting 1. Then this gets multiplied by the derivative of the inner. And the inner would be the derivative of 1 plus x to the 1/4. Now this is an example of using the d dx notation as you go through, making sense. Because if you just tried to work your way through it, you'd have to be really careful to make sure that you recognize which stage of the problem you were at. Now when we take the derivative, we get 1/4 x to the negative 3/4. And we can now bring everything else down. So that's going to be multiplied by, we've got this first expression coming down, and then we've got this expression coming down. So 1/2 multiplied by 1 plus x to the 1/4 to the negative 1/2 multiplied by 1/4, and then in front we have 1/3, 1 plus x to the 1/4 to the 1/2, all this to the exponent of negative 2/3 being multiplied. Now when we get everything together, let's see if we can do this one in one step. Draw your fraction bar. Decide who goes on top, who goes on the bottom. Now this is all, these factors are all being multiplied together, so it's 1/3 times 1/2 times 1/4. So that means you're going to have a 24 on the denominator and then a 1 on top. The x to the negative 3/4, I'm going to bring it to the bottom and write it as x to the 3/4. Then the 1 plus x to the 1/4 to the 1/2 to the negative 2/3 can come to the bottom, and it becomes this 1 plus x to the 1/4 to the 1/2, all raised to the 2/3, and then also the 1 plus x to the 1/4 to the 1/2 comes down. Now this could be written in radical form, put it back in. I'm not going to bother, mostly because I don't have the space, but we have it. So it's a messy looking question, but it actually works fairly well. Just whatever simplification you can get, in this case just the coefficients, and do that, and that's about as much as you can. So that's it. I'm just keeping this one very short, 2 questions like that. The other ones that I bypassed are fairly routine, no new ground being broken on numbers 5 and number 6. But this will take care of these type of problems. And the next thing will be the implicit differentiation, which I'll get on the next lesson. Thank you for your time.